Let's look at the directions here. Determine whether each solution is correct. If the solution is not correct, describe the error and give the correct solution. All right, if we look at example A here, let's follow the first line. What would you do to solve that equation? You would distribute the 2, correct? Do they correctly distribute the 2? No, they did. They forgot to multiply it times the 5. So they can't get the right answer now. There's really no need to even look at the rest of their work. They messed up their distribution. So no, the solution is not correct, and I didn't write this out, but the error was they tried to do the distributive property, they just messed it up. Let's look at B. If you were working this, what would you do next? Yep, they subtracted 2D from both sides. We probably wouldn't write it out like that, but they subtracted 2D from both sides. Let's see if they do it successfully. 5D minus 2D is 3D. 2D minus 2D is 0. Bring down the negative 18. They're good so far. What would you do next? They divided by 3. Did they divide correctly? They got the right answer. Let's look at C. What would you do first? I'd add 6Z to both sides first. They subtracted, and that won't work. Because on the left side, if you actually do the math for what they wrote down, negative 6Z and another negative 6Z is not 0, it's negative 12Z. That's why it's got to be adding 6Z to both sides. So they can't get it correct at that point. They messed it up. So no, and I think they tried to do the right thing. They just subtracted when they should have added. Anybody ever made those mistakes before? Yes, we all have. Try to eliminate them, but we all have. All right, so here's the learning target for today. Be able to solve equations involving absolute value. We've practiced solving, we've practiced simplifying things. Now we just got to throw in the concept of absolute value. And absolute value can be thought of as the distance the number is from 0 on a number line. The absolute value of a number may be thought of as its distance from 0. So, for instance, the absolute value of negative 5 equals 5. Because if you put a point here on negative 5, how many spaces away from 0 is it? 5. But there's another number that also has an absolute value of 5. And that's 5, because it is also 5 spaces away from 0. There's always, for any given positive number, there's always 2 numbers that have that absolute value, isn't there? All right? What 2 numbers have an absolute value of 7? Negative 7 and 7. If you make an equation out of this, if you say the absolute value of x equals 5, there's 2 solutions. Because what 2 numbers have an absolute value of 5? Negative 5 and 5. Okay? So whenever you have an equation like that, expect to get 2 solutions. All right, let's do it with negative 3. Its absolute value is 3. Positive 3. Its absolute value is 3. If we have the equation, the absolute value of x equals 3, there will be 2 solutions. X equals negative 3 is a solution. X equals 3 is a solution. Now, you've done equations before that have 2 solutions. Well, absolute value equations and quadratic equations. You've seen this possibility because remember, we talked about this one day. What is a solution? It's a number that replaces the variable and turns the equation into a true statement. If I replace this x right there with negative 3, saying that the absolute value of negative 3 equals 3 is correct. If I replace that x with 3, saying that the absolute value of 3 equals 3 is correct. That's why it has two solutions. Questions? All right. Let's do some examples. So write these down. First, we're going to do a little bit of evaluating. And when we evaluate, simplify, remember, absolute value signs are like grouping symbols. Not only are they absolute value signs, they're also like a parenthesis. So if we're going to evaluate the absolute value of m plus 6 minus 14, if m equals 4, the first thing we do is we replace m with 4, so that becomes the absolute value of 4 plus 6 minus 14. Work out and get a single number inside your absolute value signs before you do anything else. That's your order of operations. Absolute value signs are grouping symbols. Work inside there first. As you know, 4 plus 6 is 10, so that becomes the absolute value of 10 minus 14. Now, what's the absolute value of 10? 10. All we got to do now, 10 minus 14 is negative 4. Yeah, you can do that in your head probably. One of the most common mistakes students make with absolute value is you forget that it's absolute value and you think that those are ones. I don't always do it. I try to make mine bigger than the numbers so they don't look like ones. Sometimes I'll slant them a little bit so they don't look like ones, because sometimes they look like ones and you don't want that. Let's try this one. Evaluate 23 minus the absolute value of 3 minus 4x if x equals 2. First step is substitution. Let's replace that x with a 2. 23 minus the absolute value of 3 minus 4 times 2. Follow your order of operations. We work inside the grouping symbols, but inside the grouping symbol we have an order. We have to do the multiplication before we do the subtraction. Leave the 23 alone, minus, in your absolute value sign, leave the 3 alone, and do the multiplication. Negative 4 times 2 is negative 8. Continue to leave the 23 alone, minus, then do the subtraction. 3 minus 8 is negative 5. Now that we have a single term, a single number inside the absolute value sign, now we evaluate that. We all know that the absolute value of negative 5 is 5. That becomes then 23 minus 5, and our final answer is 18. Correct. So far, so good? All right, let's keep going. A few more examples. Now we're going to start solving, which is our learning target. For each absolute value equation, we must consider both cases. To solve an absolute value equation, first isolate the absolute value sign on one side of the equal sign if it is not already by itself. Now this first example, the absolute value sign, the absolute value is the only thing on the left side of this equation. Okay? Now, kind of like we did earlier, when just a minute ago, we had like the absolute value of x equals 5. We said there were two solutions, negative 5, positive 5. The absolute value of, now it's not an x, but I don't care what that's called. The number that will make this equation a true statement is, if I put a negative 17 in there, I'd get a true statement, wouldn't I? If I put a positive 17 in there, I'd get a true statement. So the expression inside the absolute value can be replaced by negative 17, or it can be replaced by positive 17 to get a true statement. That means we can do this. We say that the statement, the expression inside the absolute value sign, in this case, f plus 5, equals negative 17, or the expression in the absolute value sign, again, f plus 5, equals 17. Whatever the expression inside the absolute value sign is, it equals negative 17 or it equals 17. If that step makes sense to you, then everything else I'm going to do today will make sense to you. Does it make sense? Now, we have two equations to solve. The first one, f plus 5 equals negative 17. Subtract 5 from both sides. Negative 17 minus 5 is negative 22. Or, then solve this one. F plus 5 equals 17. Subtract 5 from both sides. 17 minus 5 is 12. Y'all know that I don't ask you to check every equation you work. But let me show you that we really did come up with the two correct solutions. So look at the check. Let's check the f equals negative 22 first. Replace f with negative 22. And then evaluate it like the previous two examples. Negative 22 plus 5 is negative 17. And then what's the absolute value of negative 17? 17, which is what we were supposed to get, isn't it? And then check the 12. Make it the absolute value of 12 plus 5. That's the absolute value of 17, which of course is 17, which is what we were supposed to get. I don't expect, in fact, I don't even encourage you to check every one of them. It gets too monotonous. Because what you do too after a little while is you figure you got it right, so you don't even you might write the check down, but you don't really think about it. Well, then that's not doing you any good if you don't think about it. Okay? All right, any questions? Because what we're going to do now is we're just going to complicate it up a little bit. But an equation like this one is the basis for everything else we're getting ready to do for this learning target. We okay with that? All right. Next two examples. We have the absolute value of y plus 2 equals 4. Now, the expression in the absolute value sign, the y plus 2, what two things have what two numbers have an absolute value of 4? 4, negative 4. That means the expression inside the absolute value sign equals negative 4, or the expression inside the absolute value sign equals positive 4. Y plus 2 equals negative 4, or y plus 2 equals positive 4. In each case, to finish solving, we would subtract 2, wouldn't we? The first one, negative 4 minus 2 gives us negative 6. And the second equation, 4 minus 2 equals 2. And there are our two solutions. Y equals negative 6 or y equals 2. Not so bad. Now, imagine some things that you need to watch out for on the quiz, though. How easy is it going to be to just forget one of those two equations? Happens all the time. Happens all the time. Students don't write that one down. They just do this, and you think you got it right. It just never enters your mind that you've forgotten half the problem. So, beware. That's a common mistake. On this next one, the absolute value of 3n minus 4 equals negative 1. Equals negative 1. Do we ever remember that absolute value of a number is distance from 0? Do we measure distance with negative numbers? If we say that from here to my house is 2 miles, we don't say from my house to here is negative 2 miles. See what I'm saying? So that really doesn't make any sense. The absolute value of a number is never negative. That means this equation has no solution. Since absolute value is a distance without direction, maybe I should say it that way, distance without direction, then you're never going to have the absolute value of an expression equal a negative number. It can equal 0. Now, 0 is the only number that doesn't have, how do I want to say this? There's only one choice. If the absolute value equals 0, isn't 0 the only number that has an absolute value of 0? You know, for any positive number, there's two numbers that have that absolute value. But for 0, there's just one number. And for negative numbers, there aren't any numbers that have an absolute value that's negative. All right. Now we're going to have to solve, we're going to have to get that absolute value sign by itself first. So on number 40 here, don't mess with what's inside the absolute value sign yet. Don't say h equals -8 or h equals 8. We're not ready for that because we don't have the absolute value of h equal to some number. That's what we have to get before we set up our two equations. Then so just think of it as if I'm solving for the absolute value of h. If I was solving for the absolute value of h, I'd add 3 to both sides. Add 3 to both sides. There's no more -3 on the left, and when you add 3 to the right, you get 11. So 2 times the absolute value of h equals 11. To continue solving for the absolute value of h, I need to divide both sides by 2, don't I? No 2 on the left, it's just the absolute value of h. And then on the right equals 11 halves. And if you want to write 11 halves as 5.5, fine. I don't care if you do or not. Either leave it as 11 over 2 or write it as 5.5. Either way is fine with me. Now I'm ready to make my two statements. H can be replaced by -5.5 or H can be replaced by 5.5. Both of those make true statements, don't they? We're fortunate enough here we don't have any more solving to do like we did on some of these examples. We already have H equals. Questions? All right, do 41. I'll uncover it a little bit at a time up here, but you do 41. Solve it for the absolute value of Q first. Everybody end up here? The absolute value of Q equals -2. Right, I subtracted 4 from both sides. No more 4 on the left. 10 minus 4 is 6. Divide both sides by -3. No more -3 on the left. 6 divided by -3 is -2. And don't trick yourself. Don't think to yourself, oh, what two numbers have an absolute value of -2? 2 and -2. The absolute value of a number is never negative. It's easy to trick yourself, isn't it? And still say 2 or -2. But we don't measure distance that way. The absolute value never, ever equals a negative number. We still doing all right? Let's see if we can't solve this word problem. The temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit, give or take 5 degrees. Find the maximum and minimum temperatures. Now, I drew out a number line. You probably don't need a number line, okay? But if you start at 80, and you could give, which means add on 5 more degrees, that means it would go all the way up to here, or take 5 degrees, it could go down to here. So in other words, if you're wanting to keep your pet snake alive, and I don't know why you would be wanting to keep it alive, but if you were, as long as the temperature's between 75 and 85, you're good. So, but the actual question, maximum and minimum. Well, the minimum allowable temperature is 75. The maximum temperature is 85. And like I said, you can probably figure that out without a number line. But, I don't know, maybe it's because you first saw number lines when you were fairly young that you kind of think, I don't want to do that. I solve problems with number lines all the time. All right, I come across it in geometry. I even draw number lines in calculus sometimes. They're very, very useful. So don't be afraid to draw yourself a number line. All right, any questions? Because that's it. You feel like you got this learning target? You just need some practice. So I'm going to have a couple of worksheets for you.